Okay, so now this is take 4. First three I had some, or sorry, the first two had some technical difficulties, and I thought 3 was going to be the charm, but unfortunately I'm long-winded, so I went past my 15 minutes and I wasn't done. So I guess I'm going to have to shorten this puppy up. Anyway, so let's talk about the core competencies real fast. Core competencies of the course were to effectively communicate qualitative and quantitative information orally and in writing, to explain the application of fundamental physical principles to various physical phenomena. Number 3 was to apply appropriate problem-solving techniques to practical and meaningful problems using graphical, mathematical, and written modeling tools. And number 4 was to work effectively in collaborative groups. These were the 4 core competencies. In addition to this, there were some course objectives. These were to evaluate scientific claims based on the actual nature of science. Number 2 is to argue various sides of scientifically controversial topics using appropriate scientific argumentation techniques. And number 3 is to communicate technical information using various media and Web 2.0 applications. So the first thing I'm going to do is show you some examples of how we were able to work effectively in collaborative groups to create presentations for specific given projects. We were able to work through those and basically come up with problem-solving ways to problem solve and to be able to effectively build the product, and then explain the fundamental physical principles behind them and what principles those were. So and to put those into a presentation that was then given and turned into to be able to be graded upon. So I'm going to quickly go through these because last time I didn't get through all these and I still have more stuff and I passed my 15 minutes. But anyway, so the first one we talked about was solar cookers. Sorry, I didn't rewind my video here. So I was actually the team lead for the first 3 projects. I actually put together the team, and I was also responsible for all of the graphics on all of the presentations, as well as my parts of the presentation. So, but I hand built all these graphics, and yeah, I wanted to make sure that we had something that was an extraordinary product. So as you can see, we have Pinky over here. He's on a solar cooker. He's on a parabolic cooker, and Brain is going to explain the concepts behind which each thing was. So in this project, we had 3 different types of cookers. I actually chose. I actually put out to the group and let them pick whichever ones they wanted first, knowing that more than likely I was going to end up with the parabolic cooker because it was the toughest, which I was perfectly fine with because it has the most potential for being awesome. And each one has a strength and weakness. So parabolic cookers, basically, I built it out of a satellite dish. And basically the pros for this one is it reaches the highest maximum temperature fastest, and it's also the only one that is able to possibly fry and grill food. It does focus the light rays into a single beam, which is very, very potent. The cons to this is it does require a lot of adjusting, fine-tuning, and you are always having to watch it, and it doesn't have any insulation. So the physics behind this one, basically in this project we covered energy, heating, radiating, thermodynamics, which is basically the study of heat and how its relations to energy and work. We talked about phase change, electromagnetic radiation mirrors, and reflection. So these were the concepts we talked about here. As you can see, this talks about some of that stuff. And also here's some examples of how we utilize graphics for graphs, which are mathematical concepts. You have your graphs to show the direction and the reflection of the sun rays. And also we talked about, like I said, we talked about phase change in here as well. This one was the box cooker. The box cooker is really good for basically cooking things like bread, soups, things that take long term. It's kind of like a crock pot. Some more graphs, just basically showing you what each one of these things is. And the nice thing with the box cooker is it has insulation. This is very similar to the box cooker, except for, or this is the easiest to build. Doesn't have near as much insulation, but it has similar concept because you basically don't have to mess with it. It's a very little adjustment. So, and they use the bag the oven bag to try and kind of act like insulation. So again, here we go showing graphs and mathematical things. So that's the first project. The second project we did was I actually did a video. We did do a Prezi on this as well, but I actually did a voiceover video for it. This one was solar panels, and in this project we talked about energy, power, Ohm's law, radiating, electromagnetic radiation, and semiconductors.
Your power that is transferred out and allows us to be able to utilize that. The level at which energy can be transferred, and you can take them back and forth. So,
trying to get to where you can see the whole.
Okay. These circuits and these panels.
Yeah. So basically, here you've got Pinky's in the light socket, and he's getting the solar panel there. But it also talks, it has all of the fundamentals. Once again, just like in the first project, you have all of your fundamentals. It talks about the process that we used, each person, and it also talks about the different designs. In this project we had to come up with both a series circuit and a parallel circuit, and explain what are the purposes for each and the strengths and weaknesses of each. One you have high voltage, the other one you have high amps. And they're different purposes. But one of the things I did mention and I wanted to talk about here with my interview with David was I've been an electrician for a long time, and recently because I'm back in school, I've been doing few side jobs and things like that. But I was wiring up a steam shower the other day for somebody, and I was talking to David about this because I never really fully understood how it exactly worked with alternating current, because on a 220 circuit you actually have two powers. You have a black, and a red, and basically on the steam shower they don't actually use a common, which would normally be a white wire. And I was trying to, and I understand it works. I've always known, hey, this is how you wire everything like that, but I never really understood the full principles and how it actually transfers. One acts like a common while the other one acts like a hot, and vice versa. That's why it's called alternating current, which I don't know why it never dawned on me, but it was pretty cool. I was very excited that I fully understood how it all worked now. So that was a pretty cool experience. Let's go to the third one real fast so that I can make sure I get through everything. The third project was coil guns, and we made these based off of we used a disposable camera, and we removed the flash and the circuit board, and basically we were able to create a coil gun which shot a projectile by the use of the battery, and basically the coils within the circuit, and the transistors and the transformers and the capacitors and all the stored up energy, and whenever you hit the button it releases all the energy quickly. And by your homemade coil wrapped around, I use a straw, it actually creates an inductance and pulls the projectile in, and when it shuts off it shoots it out. So it's pretty neat. I really like this. I like this project. However, I wish it would have been, I wish there wasn't so many restrictions, but I fully understand based on today's environment and lawsuits and all the other things that it's POA. Anyway, so yeah, on this one, basically once again custom graphics. Pinky's being shot out of a cannon or a coil. It's electromagnetic coil. But anyway, once again showing basically your mathematics in maximum range. This was our chart, or this was my chart. I shot 3 shots that are right around 3 meters apiece, and our initial velocity was calculated 5.4 meters per second. I don't know 100% for sure if I was completely accurate, but I felt fairly strongly about it, so hopefully it was good. Terminology we covered in this project had a lot a lot of terminology and fundamental physics principles that we talked about: charge, current, voltage, resistance, inductance, magnetism, Ohm's law, Lenz's law, conductors, insulators, resistors, capacitors, transformers, diodes, transistors, batteries or cells, and light generation. So we covered a lot of this stuff here. This is written, and like I said, we orally covered it as well. Here's our build schematic. A couple of different pictures. This one over here on the left is actually my coil gun. This one here, I believe, is Shauna's. But this one shows you have your different coils. This is basically your transformer. It's boosting the energy. It then puts it into the transistor, or puts it into the capacitor, stores it in the capacitor. When the trigger is shot, it immediately shoots it through, pushes it out here, which creates a magnetic field and pulls the projectile into the barrel. When it shuts off, it blasts out. And if you don't time it right, or if you don't set it up perfect, then sometimes it shoots backwards, or sometimes it doesn't go anywhere because it just sticks right here. Poing. Anyway, that's that. Our fourth project, I gotta hurry up, was our cold laser therapy. Me and Kevin Williams did this project. We actually went down to Huhukam Memorial Hospital, and we did cold laser therapy, which we covered a lot of electromagnetic magnetic radiation. We talked about what are the uses of it, how it works, and we threw in a few different things here and there. But this one we talked about the spectrum of light and how this is using a non-ionized range wavelength, which was infrared light, or very high red to ranging into infrared, and basically how it increases the heat in the hemoglobin, and basically allows more oxygen and stuff to heal, to allow the body to heal the area quicker, and creating more ATP and all that other stuff. So this was actually a really cool project. We really liked that and learned a lot. But I want to go over this other stuff real quick. We did the controversial debates. So these are, you're talking about the additional course objectives now. We argue different scientific or controversial topics using appropriate scientific argumentation techniques. In this, I basically went through and I covered every single one. I did a pro and a con for each one, and then I actually went back and cited sources for each side. And then I went back through and basically gave my own opinions on each and every single one. Let's see, what else? As you can see, we were able to communicate our technical information using different media types. We used the Prezi, we used screencasts, we used this bulletin board. What else? We used YouTube videos. We also basically went, each week we had specific neat resources that we had to find for specific topics. Every single week I posted something, and I also posted responses to everybody else's posts. Let's see what else. We had additional videos and things like that, and argumentations. We did a cultural science paper, where basically I went to the Science Museum and I provided different videos and different things like that, with my experiences, and explained different topics. And I found that to be very interesting. It's been a long time since I went to the Science Museum, but I really enjoyed that. The things I like most about this class, I really like the project-based learning, and essentially the fact that you can actually see how the fundamental principles work on each project. I wish that with projects going forward that there were things that we can keep and utilize in the future, and that would make it a lot better. I would say I easily spent at least 8 hours a week. Sometimes I spent more, and a few weeks I spent a little less, depending upon how busy the week was before. But that was pretty much it. So in a nutshell, that was my semester, and I appreciate it. Thank you very much. I learned a heck of a lot of stuff, and I'll talk to you later.